So, oh, we are live. Okay. So, hello everyone. I'm Cristina Peristeridou. I'm assistant professor at the Faculty of Law and member of the Executive Board of FEM. I would like to welcome you all to the first Women Researchers Festival of Maastricht University that FEM co-hosts with Pint of Science. This is the second session. After having a very successful first session, we are going to hear more research. As you may know, FEM is a network of staff at Maastricht University with a mission to promote the empowerment of women and female leadership and to foster a culture of gender equity and diversity at our university. So this event is to celebrate the innovation and curiosity and the daring nature of women researchers at UM, and also to honor the International Women's Day, which is today. We would like to provide a platform for women researchers to share their research and, who knows, perhaps to even foster collaboration between us. We have been more than happy to set this up together with Dr. Anna Soet from FPN and Pint of Science, which dedicates its work to make research open and accessible. So, as I said before, this is the second session. We have in total for today's event 16 researchers divided into 2 sessions. In this session also 8 researchers will take the floor to present their research. I must say that we received quite the amount of applications, so we really had to make a hard choice. But those not chosen to present have been offered the opportunity to still publish the research via poster, which will be shown at the website of Pint of Science later today. So with no further ado, I would like to give the floor to the researchers. Each presentation will be about 5 minutes, and then you can shoot your questions, and the researchers will answer it the next 5 minutes. Also, I must say that please note that the event is recorded and will be shared on social platforms later on. So, let's begin with our first researcher, which is Dr. Simone Verhaayen. She's a postdoctoral researcher at AFHML. And today she will discuss with us her research on personal well-being in a daily environment.
Yes, thank you. Can I share my own slides, right?
We see them.
Do you see the first slide?
Yes.
Okay, so I'm going to talk about my research on personal well-being in a daily environment. And on a daily basis, we do tons of things. We get up, we take care of ourselves, we groom ourselves, we provide food also for maybe our kids. Then we go to work, do some households. We have to think of, just have some sports in between them, some relaxation. So we're very, very busy. And sometimes unexpected things happen. So, for example, you get a phone call by a family member asking you to do the groceries because they're not feeling too well. And that changes our plans. And that can be very challenging and sometimes also stressful. So what is needed is that we have to find a good balance to deal with this. And especially during COVID times, this is becoming very apparent. And so we need to be flexible, we need to be resilient to all those events. And sometimes you feel yourself sort of blue, not too well, and it can be very difficult to pinpoint what is going on, but you're a bit depressed, not sleeping too well. And then it's good to find out how to deal with this. So there are several strategies that you could take. You could, for example, go on the internet, look up some symptoms that you're experiencing. You can go to a mental health professional, talk about the complaints that you have, but you could also just talk to neighbors or family, friends. So you find out about others' experiences. And this can be, this is very helpful, but then you need to apply it to your own personal situation. And what is important is that you start to zoom into your own daily life and zooming into finding out when you're feeling well and when not. And mobile health tools can really help with this because they can you can use them in your daily life. when needed, you can focus on change over time, and it's an accessible methodology. And especially the experience sampling method, and that's what my research is about. It's a daily diary method that helps you to monitor your feelings throughout the day. And the best thing is, I'll explain in a bit how it works, but it helps you not only focus on on your symptoms and your vulnerabilities, but also on moments that go well. For example, a question would be, when do you as a person feel better? So how does that work? You get an app on your phone, and that prompts you several times a day to fill in a short questionnaire. And this questionnaire is about how you feel at the moment, what are you doing, with whom are you, what do you think of the situations, or just clicking through and scoring them in very quickly, like 1 minute, always the same. But when you do that repeatedly across days, then you get a very rich data set that you can explore later. So if you collect the data for a week, for example, you can go online. For example, when you use the SciMate app, and then you can log into with your own credentials and see your own data. And we present this data back through graphs and figures, and you can dynamically explore this. And well, this methodology has been used for years, and especially in research, and we learned a lot from it, especially on...
Sorry to interrupt you, but we only see the front slide. I don't know whether this is your intention, or would you like to...
Oh, that's not my attention. Did you see this?
No.
Let me click through my beautiful slides. I'm very sorry.
Oh, so this nice indeed.
Yeah, this was about finding balance. This is feeling blue. You have some strategies for internet or talk to people. Zooming into your own experience. And then I was talking, I think, on mobile health. And then especially the experience sampling methodology, which works through these questionnaires. And this is where I left. It's so the methodology learned us a lot through research on dynamic patterns, on the micro experiences of psychopathology, and now it's also used in clinical practice. So it's being used in the hospital and at Mondrian, where I work as a psychologist, for example. But it's being used sporadically and with insufficient use of its full potential. And I think that's a shame. So we do have a lot of research questions, and that's where I come in too. For example, the ESM as a mobile health tool is very excellent for learning from data. But we provide this data back in graphs and figures, and they need to be easy to interpret by people. And as a researcher, we are responsible for providing reliable data back. And one of the risks is under-interpreting these results. And so we need more research on that and explore via data how it works in different people. And another thing that's lacking from this daily environment is because we're talking about multiple domains on symptoms, on cognition as well. And cognition is especially relevant for recovery of mental health problems. We're less able to concentrate, and it fluctuates throughout the day, but we're not really able to measure it yet. So I developed some cognitive tasks that go within this questionnaire, and I'm currently working on how to, if they're very valid, and what do we learn from them, contextualize. So that comes to my goal. My aim is to develop solutions to recontextualize mental health care and especially empower patients in their own recovery. And I focus on expanding relevant outcome measures in this tool. I design them, I test them using data simulation, but I also test them in clinical practice. And this is really, it has to be implemented. So end users, like patients, are involved from the start, clinicians, and I propose a lot of small scale studies. So I think of a solution together with patients, then we build it, we test it, we get our feedback, and then we adjust it again. So to really make sure it has a daily life impact. And this is my research. Thank you.
Thank you for this very interesting topic. So let's see whether what questions we will get. It takes always a minute until they are until they appear onto the screen. Let's see. Until that happens, I have a question, like, in which stage of research are you now? So you mentioned that you already start testing, but so
so this is an ongoing process. My whole PhD was about bridging this gap between clinical practice, mental health care, and research for this methodology. So we can already use it, but I'm currently working on developing these cognitive outcome measures. That's really novel, and you need to build on the evidence for that. So we have working tasks, but we are now testing it in patient groups and see how they work and how you can communicate results back to people.
Okay. And what kind of, sorry. Oh, yeah. Thank you for this interesting presentation. I'm wondering whether there's an inherent bias on subjects to report mostly their negative feelings, and how.
Yeah, so that's a very good question. The design of the questionnaires is very well thought of. So we don't only ask about negative feelings. It's, for example, I am feeling enthusiastic on a scale of 1, not at all, to 7, very much. And then we also ask about a negative mood. I'm feeling anxious, for example, but we do balance them out. So this questionnaire is really designed to have not so much of a influencing mood of people.
Another one, recently there's a lot of attention for teenagers suffering from mental health, especially with COVID. How do you take this into account? How could you?
This is a very good question, because I think it's a very nice example of how you could use this methodology, for example, also to find out on a daily basis, what can I do? For example, to someone, it's very important to have social contact, and especially for youth, staying at home, not being able to go to school. And those things you can really, it's being used as ESM. You can try it yourself. It's, for example, by downloading the SciMate app. But by exploring, you can find out, okay, I really, it's good for me to spend time outside. Otherwise, I'm feeling too much negativity during the day. So you can really explore. But it's very relevant for youth as well.
Let me see if more questions will load, or I think that's it. Okay, so thank you very much, Simone. Good luck with the rest of the research. I think it's an extremely interesting topic you have there with many applications. So I will be pleased to see what comes up. Okay, thank you. And let's move on to our next researcher, which is Alex Thompson. Alex is a PhD candidate at FPM and AFHML, and she will discuss mechanisms of brain stimulation, which already sounds extremely cool.
Thank you. Okay, so I will now just switch my screen. Okay, so I want to start by thanking the organizers of the event very much, and also for inviting me to give a talk today. My name is Alex Thompson, and I've prepared a couple of slides about my PhD research, which I've actually just completed. And the topic is taking an interdisciplinary approach to understanding the mechanisms of brain stimulation. Can you see the next slide? Yeah. Okay. So the type of brain stimulation that I have been using is called transcranial magnetic stimulation, or TMS for short. And TMS is a non-invasive type of brain stimulation. And how it works is that electricity is sent through a copper wire, which is wound in a loop. And I've indicated this in this white icon here. And so when electricity is sent through this coil, an electromagnetic pulse is created, and this pulse can then pass non-invasively through the skull and activate the cortex underneath. So for example, if you place the coil on the motor cortex, you can directly activate cortical spinal circuits and make the finger move. And while this is really cool, it gets much more interesting when multiple pulses are given in a repeated fashion, so like in a specific pattern, because then you can create lasting effects on brain excitability. So for example, you can increase or decrease the activity of a particular brain area for a short amount of time. And this is useful if you want to, for example, study how a particular brain part works or is involved in a task. But TMS is also used a lot in the clinic, where it's a treatment option for treatment-resistant depression. And so despite all of these uses, not a lot is known about the actual mechanisms of TMS. So this is important because not only do we need to know how these tools work, there are quite a lot of people who do not respond to TMS. Yeah, it's important to understand the mechanisms so that we can better tailor these patterns of stimulation protocols to make people more responsive. So currently, understanding the mechanisms is normally done indirectly in human participants. So for example, like I told you, stimulating the motor cortex and making the finger move. And then you can quantify how much this finger movement changes after a certain protocol. However, like I also told you, there's quite a lot of variability in responsiveness. And so these outcome measures, are quite variable. So another approach could be moving in vitro. And this is where the interdisciplinary aspect comes in. So what you can do is grow human neurons in the lab. So for example, in one of these little Petri dishes, you can see also in white here, and look for changes in the neurons themselves after brain stimulation. So for example, looking at changes in how the neurons connect, their shape, different changes in molecular markers, and then we can better understand exactly how the stimulation is working. And so my PhD research focused specifically on this. And so what I did is half my PhD was in human participants. And here you can see a picture of me stimulating the motor cortex. And the other half was in neurons. And so here you can see an example of what these neurons look like. They're nice long green axons. I would stimulate these neurons in the lab. And I combined these two different studies to better understand how TMS works. So for example, here's how that would look. So I have a TMS coil here and the dish immediately below. And what I specifically wanted to do was to find some outcome measures which could indicate if neurons responded or not to TMS stimulation. The idea with all of this is that maybe in the future, we can use TMS stimulation. We can better tailor TMS stimulation. So we can identify outcome measures in these neurons and then determine whether they're responsive or not to TMS. Then we can take specific neurons from human participants, grow them in the lab, and see which protocol would best fit the human participant that they come to, with the hopes of actually personalizing treatment and hopefully promoting better stimulation protocols. That was all I have. I look forward to your questions.
Okay, thank you, Alex. This is extremely interesting. So let's see what questions will fly into the screen. Immediately. They are not treatment resistant. Okay.
Yes, good question. Yes, so right now, the FDA has approved it as a treatment option for treatment-resistant patients, but it is effective in patients without treatment resistance as well. It's just normally pharmacological intervention is the first line, so that's why TMS is normally done with treatment-resistant patients. But I think there have been some preliminary studies showing it's maybe even more effective in not treatment-resistant patients.
Okay. Until the second question loads, maybe I would like to ask one of my own. Are there any negative effects of TMS or?
Yeah, side effects. Yeah, exactly. So it can cause, for example, a headache. I mean, you have this coil on your head and there's some pulses. It's a little bit loud. So yeah, kind of the negative effects are just the uncomfort of having an electrical pulse on your head. But other than a headache, there are hardly any side effects.
So this overstimulation cannot create further problems, no?
No, I mean, of course, you have to go through a screening procedure before you can have it. So to check for contraindications, because I mean, there's risks if you have something that would predispose you to seizure, for example, but no. with the screening, it's very safe. Yeah.
Very promising. Okay. Oh. So how did you choose your cell line?
Yes, also a good question. So the original cell line I used is called SHSY5Y. So they're derived from a tumor, and you can grow them quite consistently in the lab. And the reason for starting with this human cell line is because it has been used quite a lot. So there's a lot of documentation of what you should see when they're neuron-like or differentiated. So it was a good model to begin with because there is this documentation. But the next step would be to move to more accurate human models, so iPS-derived cells. But this was how we chose the first one because it is such a well-established line. And the most challenging aspect of cell culture work, for what I found, is that the cells are ready when they are, and you can't really plan your schedule around that because they're just ready, and it can be a Easter weekend or it can be the evening. And this makes it hard to plan because you just have to be ready all the time. And yeah, this is what I found challenging about the cell culture work.
One more.
Does TMS improve the efficacy of pharmaceuticals? Also a good question. I think from at least what I know, they have mostly used drug naive, after washout periods. So I'm not actually sure about the interactions between these two. I think there is research going on about how pharmaceuticals and TMS can interact, but I think safety reasons make it important to, wash out current pharmaceuticals in the body, so you don't know how, because you don't know how they interact with brain stimulation all the time. So I'm not exactly sure about it, but I think the research is quite preliminary in this area.
Okay, thank you so much for this very interesting research. Let's see.
Great. Thank you.
So let's move on to our next researcher. We have Dr. Anna Harris, who is an associate professor at FASOS. And today she will present her research about a sensory education. I'm most intrigued, I must say.
Great. Thank you very much. So I'm just wondering, when was the last time you went to the fridge and threw out something that was past its use-by date? Did you smell it or taste it before you threw out? Well, no. Well, there's a big campaign happening in the UK at the moment, which is encouraging people to look, smell, and taste their food before they throw it out to avoid food waste. So what they're trying to do is train our senses to help us save the planet. This is just one of many examples I just drew from the newspapers a couple of weeks ago, which show these everyday acts of training our senses, which I call a sensory education. And today I want to talk about a few of these that draws on my research that I have done as an anthropologist, studying how people train their sensory skills of observation. Now, most of the time I do this amongst doctors. So I'm really interested in how do doctors train their skills of listening to sounds or palpating a tumor. But I also grew a real interest in this in food and other areas as well. So what I want to do in my very short time I have with you is dispel 5 myths about sensory training. And I'll go to the next slide. So the first myth that I want to dispel is that training of the senses, that there are 5 senses that need to be trained. And also that there are sensory organs which go with these senses. So it's often thought of that the ear listens or the eyes see. But actually what a lot of scientists and also social scientists have done is dispel this myth that sensing is a multi-sensory activity. So if you take a practice of doctors like percussion, when they feel your chest to look for sounds, this is a practice which is about sound as well as feeling, both in combination. And there are many other senses besides the 5 that researchers look at. So in different cultural contexts, you might emphasize movement as a sense, or you might think of the sense of knowing how to touch your nose when you have your eyes closed, called proprioception. So there are many senses. So I'll move to the next slide, which is the second. So basically what my research does is dispel this myth that there are discrete categories and we extend beyond them. And the second myth I want to dispel with my research is that sensing is innate, that it's something that we are born knowing how to do. But actually what I want to show with my research is that sensing is something that we learn. And there have been a lot of work. Sociologists, for example, have done work which you might be familiar with, say on taste, which shows that the way you sense the world is impacted by your environment, say class, for example. But what I affiliate more with the researchers that look at how sensing is cultivated, that it's not just something that happens when it's in an environment, but something you need to work on. And here we can see different professional contexts where you've got a professional deodorant tester, for example, who trains their sense of smell. Or this is tea tasters. So you've got this professional expertise in tea tasting. But what I'm really interested in is not only these professional domains as well as medicine, but also these everyday acts of sensing that we're trained, like knowing when food is off, for example. So I want to move to the third myth that I want to dispel with my research, which is that sensing is, and that's on the next slide, which is sensing is only for children. So those of you, for example, who have children that might go to a Montessori school or some kind of context where you learn to letters with sandpaper and feel, for example, might see this scene might be familiar. And essentially there's a lot of emphasis on children training through sensory input, whether it's the squeaky toys or things like this. But what I want to show in my research is that we never stop training our senses, and that sensing and sensory inputs is actually a really good way to have in our educational processes as well. So I'm interested in exploring that. The fourth myth I want to dispel is that we only learn in person, and that's on the next slide, that we learn from a master or apprentice. And that is basically that anthropologists have been very interested in how we learn in these contexts. And I want to look at how these resources and materials, like a wine tasting wheel, might train our sense of tasting a wine. Or this is a urine analysis wheel, which doctors used to use to smell and taste urine, for example. So there are many resources which are involved. And the last one I want to dispel, this myth, is that the digital kills the senses. And this is on the next slide, which is that there's often this idea that digital technologies will destroy the senses. In medicine, this is often an argument that doctors no longer listen or touch or feel. And I argue instead that the digital is enmeshed in our sensory experiences. So in summary, in my next slide, I just want to argue, and I do this in a book which I've just published, which I'm grateful for this presentation to talk about because it's been out for a month, but with childcaring, I have not had a chance to talk about it. And it's called, on the next slide, A Sensory Education. And I argue that sensing is a social and material practice. And you can find it, it's free online. And the last slide is to thank my great research team. I'm a member of a research team and that I've drawn on for this research called Making Clinical Sense. It's got 4 people involved and it's funded by the European Research Council. So thanks very much.
Thank you, Anna, for this fantastic presentation. And I think it would be great if you could send us a link of your book, and maybe we can also add it with your presentation after the event when we at our website. So, and congratulations for the book. Now let's see what questions we're going to get. I have already 2 because I do have children. So your presentation. Oh, okay. So I was curious. Oh, okay. Maybe this then it changed. I'm curious on what you mentioned about senses in different cultural backgrounds. Does it differ across cultures? Good one.
Really good. Yeah, great question. So, for example, here I draw mostly on research of others when we talk about this. It's often seen as this Western categorization of 5 senses. But when anthropologists go into different settings and they realize that vocabularies are different, people might not talk discreetly about sound or touching. And some anthropologists have described, for example, different societies or communities which rely a lot more on different senses, so sound, for example. In my own research, we do look at 3 different settings in West Africa and Central Europe and West Europe, and we look at how different settings train sensory skills in different ways. But we look at all of the material aspects of this environment, not only this kind of innate cultural idea that we're born with different kinds of sensing abilities. Yeah, that's a great question.
Yes, Sharon does have very good questions. Also in the previous speakers session. Okay, so I don't know whether some new questions will pop up. There was one that went too fast, but in the meantime, can I ask? So, because for us that have kids, the sensory these sensory games that they play when they're toddlers, where they touch the soil, this is really encouraged by professionals. Do you think it is as important as they say it is, or is it just one of these trends, you know?
No, I think it's really important. I think that actually sensing the world through soil and getting their hands dirty and all of this is really important. And what I think is actually important to do is to realize that as adults we need to learn more that way too. So we spend so much time on digital screens. It would be great if we could have more learning experiences where we're also digging in soil, growing gardens, or exploring research questions where we also get our hands dirty.
And I actually have one more.
Yeah, please.
Also about children, sorry.
Yeah, no, please.
I think recently what is really popular is this sensory processing disorder. Where kids are being diagnosed from that, like it's a new thing. I don't know whether it's new, but you see it a lot. Is it something? Is it something that you look at in your research, or is it something that you see adults having an issue with, or how does it fit with your research?
Yeah, it's a really good question, because if you type in sensory education, you come up with all these resources for parents who are struggling to kind of find ways in which to kind of basically create conditions which are facilitate being with children who have been diagnosed with this or they suspect. I don't look at it. I have a little section in my book which has said all the fascinating areas of research I don't look at. The other one I don't look at is animal sensing, because I mean there's a whole amazing world of research on animal sensing. All I can really think of is that we would have a lot to learn from each other, researchers who are looking at this, also mindfulness and different kinds of practices which really attend to the senses as a way of therapy, or but yeah, I don't look at it myself, but I would love to think, if anyone wants to collaborate and talk about that, I'd love to. I'm
sure after this presentation you will get a lot of requests. So, thank you so much. I'm informed that your book has already been posted, like the advertisement, in our FEM website. We're fast.
Thanks so much. Okay. Thank you.
Thank you so much. And let's move with our next researcher, which is Dr. Carrie Voss. She's assistant professor at FSE, and wow, she will discuss theoretical particle physics. I love this topic, and I know so little about it. So we can see your first slide. Yes.
I was still muted. Hi, thanks a lot. So first of all, thanks for the organization for this super great event. So I wanted to give you a little bit a pint of theoretical physics. And I realize it's a bit different from what we heard so far. And I think this cup here on the left shows really nicely this pint of theoretical physics, which I'll come back to. But of course, this is very broad, right? So let me narrow this down a little bit for you. What do I do in my daily life? I actually hunt for these tiny, tiny imprints, tiny footprints of new particles that we could see in known processes. So let's go back first to this cup. So this cup is actually quite wonderful. So it has this one equation on it, but this equation actually summarizes what we know of particle physics. It's so-called standard model of particle physics, which is depicted here on the right. So the first line describes the known forces that we have, actually 3 of the 4 known forces, and their force carriers here. The next line describes the fundamental particles. So these are separated into so-called quarks and leptons. So the leptons are, for example, the electrons and the muons, and we have 6 of each of them, and they are actually nicely categorized into these families where they have like a little bit the same properties. So we have 3 families, as we usually say. And then we have the Higgs boson, which actually connects this whole thing by giving all these particles mass. And as you might remember, this Higgs boson is really the missing piece of the Standard Model and created a lot of excitement when it was discovered in 2012 at this Large Hadron Collider, the LHC, at CERN, and was also rewarded the Nobel Prize in 2013 for physics for actually the theoretical postulation that this particle had to exist by Higgs and Angler. Now, this Standard Model that you see here on the right is actually really remarkable, but this is really what we know. It summarizes what we know at the moment of particle physics. And it has been studied, of course, in a great details, but there's also some things that it doesn't describe that are missing. So like I already said, we have 3 of the 4 forces. So what is not included is so-called gravity, which you of course know from our daily life. So this is not included. And there are some other things that are missing. Like, for example, you might have heard of dark matter. This is unexplained by the Standard Model, cannot be explained. We also have this disbalance between matter and antimatter in the universe. Actually, the reason why we exist, there's more matter than antimatter. This we can also not explain with the Standard Model. We have 3 families only, like I showed you. Why not 4? Why not 5? This is also a question we have. And there's also a specific hierarchy in all the masses of these particles and their couplings. And we have no answer for this. We have no explanation why that would be there. And we have actually some other questions. So in general, this leads us to believe that there must be something else, something new particles, new interactions, new physics to answer these questions. Now, if you think about how can we then actually discover these new interactions, how can we find this out? Well, we do this by really zooming into the Standard Model. And this we can do because we have this really incredible amount of experimental data on the one hand, so from the LHC, but also from other experiments called Bell and Bell 2, so B-factory experiments. We have, of course, the theoretical advances, which I'm also working on. And this together really pushes us into this precision frontier where we really have a loop and we can really study all these Standard Model processes in great detail. And so far, the Standard Model passed all the tests we could think of. And we have no evidence, no conclusive evidence for new physics so far. So that's my research, or the research we do in our group, in the Gravitational Waves and Fundamental Physics group here in Maastricht, is really study the Standard Model with high precision. Why do we do that? Well, the explanation is relatively easy. So if we would have new unknown particles, this would leave an effect. This would leave a tiny imprint, a footprint in these known processes. And my job is to actually understand really with high precision the predictions of what the Standard Model says. And then we have those predictions. We take the experimental data, compare the two, and if we see a mismatch, a misalignment, we know something is wrong, something is missing. So that's actually the easy way to explain this. And more specifically, I do this by looking at B mesons. I already mentioned it briefly. So a B meson is actually depicted here on the left. So it's a combination of the B and the D quark, which then decays. And I study specifically so-called rare B meson decays, which of this one in the box is an example. And so what you can see maybe is you see a loop diagram. Now, always if you see a loop, this means that this decay is suppressed. So it's rare. It doesn't occur very often because it's dominated by these loops. Now, since that's so rare, actually what could happen is that new physics would enter, since it's usually a small effect, but it could be that this effect is at the same level, so they kind of compete with each other. So these decays are usually super sensitive to new physics. Now, actually, what we found out is that something super curious, something peculiar is going on with these decays. Because if you look at these decays, you have to believe me if I tell you this, but in the Standard Model, we have here these leptons I was mentioning before. Now, the decay to electrons and muons in the Standard Model is really supposed to be the same. So if I take the ratio of the two, probability should be 1. No question about this. But this is actually not what is found experimentally. So I give you here a plot of the LHCb collaboration, also at CERN. And you see here this ratio defined like this. So really the muons versus the electrons. Standard model prediction, exactly 1. And this is the experimental data. So you see that there is a discrepancy, a deviation. Now, this deviation at the moment is not yet conclusive evidence. It's not 5 sigma, as we call it. But it's there, and it's actually the only hint that we have for new physics. So we're all super excited about this, and we really need more data, more precision to find out if this is new physics or a statistical fluctuation. So if you're interested, stay tuned like we do, and you can click on the links to keep updated on the LHCb public page for the general audience. And what we hope, of course, is we keep studying this with our group, and we hope, of course, that this gives us then some insights towards our final goal, which is a new standard model, where all these extra pieces of the puzzle fit together, and this really answers all our questions. So if you have other questions also later coming up, please feel free to contact me. I'm always happy to discuss this. Thanks very much.
Well, thank you for this presentation. I mean, I don't understand much, but I do understand a little bit, so I can ask this question. So this comes from me. So at which point can you say that these are not hints anymore of new physics?
Right. So this is a really good question. So I was mentioning this a little bit. So if you look, you don't see my slides anymore. So usually what we say is that you have a measurement, right here, exactly. So you have a measurement here, and you have an error bar on this, right? So you have the mean and you have the standard deviation. And now we just have because of course, this is the question that always comes up. So we say if the standard, the deviation is more than 5 sigma, so that would be in this plot. You see here, this small error bar, if you would have 5 times that away from the standard model, then you claim a discovery. So this is really well defined because of course this question always comes up, but you can still wonder if this is the way to do it. At the moment, we have about 3.
Okay, so it did happen one day that you saw this going up.
That's what we hope for. If we have more and more statistics, yes.
Okay, good. Okay, so let's see any more. Oh, yes. Do you know of any other initiatives? Oh, no, sorry, another question. Amazing hearing my first question. Where can I get a mug like this?
Yeah, I must say, I also don't have this mug. It's a really famous mug. There are also T-shirts. I think at the CERN, I think they have also a gift shop. But I also have to do some research about this. I will let you know.
Okay, that's an important part. Okay, good. Okay, have developments in computational capacity helped in investigating new physics?
Yeah, absolutely. So this is, of course, at the moment still mainly from the experimental side, because you have really millions and millions and millions of collisions at the LHC per second even. So you have to, in order to get the plots that I was showing, you already have to throw away a lot of background events, etc. So this is really high. This is all big data and a lot of machine learning involved. And we're actually also going towards doing a bit more machine learning for the theoretical explanations as well.
Okay, what is the current experimental data? What if the current cannot complete the puzzle? What's the next step?
Right. So that's of course an excellent question. So we were also, let's be honest, we were a bit surprised to see some hints of new physics in these decays, because if you would have asked people before, it's like, what's the only thing that is really fine in the standard model is electrons and muons are the same. And now we find a deviation here, and we don't find deviations in other candidates that you might think of immediately. The easy question is we need more and more precision. So if this turns out to be new physics, we will just continue. We will find explanations for this. But if it turns out that we need more, we will just go better, even with a better loop, and see what else could there be.
Good luck with that. So we have Linda, from Linda, how do you think the possible Einstein telescope will contribute to further advancing this research? Oh. What are the chances?
Okay, good. So, okay, that's an interesting question. So, of course, like I said already, so we have the missing pieces of the standard model is like also how dark matter contributes, dark energy, how gravity can be completed, etc. And of course, for this, you need really like to have this flavor physics, what I'm doing here. So really things at the LHC with really particles. But of course, you also need the other side from this, which is a bit more like the cosmology side or the gravity side, right, to really complete this puzzle. So I don't see this so much as a chance to win the competition, but it's really like curiosity-driven research. We really want to know what's going on. So we collaborate with a lot of people from a lot of universities, countries, different fields. So it's really, but maybe the best answer to this question is, well, you're completely right that we need interdisciplinary research to tackle these big questions.
Okay, thank you, Carrie. That has been most amazing. I think your research answers really the big questions. So good luck. And
thanks.
Thank you so much. And I think it is time to move to our next researcher, which is someone from my faculty, Andrea Grigoriou. She's a PhD candidate in the law faculty. Yay! And her presentation will be about abusive language on social media data. So, Andrea, you have the floor.
Yes. Can you see my screen? Is everything all right?
Yes, we can.
Yeah, so my PhD topic revolves around abusive language on social media. And yes, I do work at the law faculty, but it's a bit of a weird story. My background is actually in computer science. So I have a master's degree in artificial intelligence, but now I'm trying to basically apply that knowledge into the legal domain. So first, I wanted to talk a little bit about why should we actually care about abusive language on social media, because some people seem to think that it's maybe not such an important issue and so on. So actually research shows that more than 50% of online harassment cases happen on social media platforms, and there's one or abusive or toxic statement actually being sent every 30 seconds. And these can create emotional stress, which affects 1 in 10 people. So online harassment and abusive language specifically is being tackled both into the legal domain, but also into the computer science domain. But what ended up happening was that these two domains were kind of trying to solve this problem separately without really collaborating. But as I'm going to show here, the legal approach has its limitation because they don't have the computational power to maybe see the problem at a bigger scale. And then on the other side, the computer science approach doesn't really focus on the background of the issue and how can we solve the issue with definitions that have been proposed by domains such as the legal domain. So the legal approach is usually for online harassment and hate speech and so on is to use existing legislation created for the offline equivalent of hate speech, which sometimes doesn't really translate that well in the online environment because they are similar but not the same. Also, research conducted shows that there's need for new regulations. However, we have some tools already, such as the Code of Conduct from the European Commission, which was founded in 2016, but it's only a recommendation at the European level of what platforms should do when they encounter hate speech and hate online. And what is mainly being done is to explore this phenomenon with a specific case or a few specific cases throughout the years, compared to taking multiple cases at a bigger scale and analyzing the data in that way. On the other side, the computer science approach is mainly tackling text classification. So they take hate speech as a text classification task, and they try to just put these statements into binary boxes such as hate, non-hate, harassment, or non-harassment. There's some approaches that try to look at multi-class classification, where they try to see the type of hate speech, such as sexist, racist, and so on. And a few approaches also to look at the levels of hate. So if it's weak hate, strong hate, or making the difference between an offensive or a hateful statement. One more newer approach is to actually leave aside just the text, the isolated text, and to actually look at the target of the hate to classify it if it's an individual that's being targeted or if it's just a generic hate statement, but also to take a step back and actually classify the user by taking a sample of their tweets or their comments to see if the user is actually hateful user or not. So how can we actually enforce online harassment regulation? But I would actually first want to take a step back and actually ask if we fully understand the phenomenon to find a proper answer. And unfortunately, both the legal domain and the computer science domain can't really answer this at the moment. So we don't know yet how the abuse actually looks like. Is it always hate speech? Is it sometimes just abusive language or offensive language? What kind of types of hate speech are they out there? Does a one-size-fits-all approach work on all platforms? Because this has been presumed in research throughout that if we find something that works for Twitter, for example, in computer science, we should just take it and apply it on other social media platforms as well. Who will actually regulate the phenomenon more efficiently, social media or the legal system? Because right now there's this battle between social media trying to tackle the issues through community guidelines and content moderation and so on, and the legal system kind of staying a bit in the background and trying to control everything. And also what kind of strategies exist to actually deal with the phenomenon and how effective are they? So my idea was to actually, instead of tackling this issue with two separate domains, to actually collaborate. So, and my research question specifically for one of my projects is how can legal provisions be transposed into a computational framework for identifying abusive language in social media text? For this, we have a project called Abusive Language on Social Media Data through the Legal Looking Glass, where we actually collected YouTube comments from selected YouTube videos with controversial discussion topics from different domains, such as veganism, gender identity, and workplace diversity. We also have multiple video types, such as official videos, which are the videos that can be posted by official sources, such as documentaries, news channels, and so on. Then we have the personal videos, which are the videos the most popular videos that you can find on YouTube published by influencers, and reaction videos, which are reaction videos usually posted in response to personal videos, but they can also be posted in response to official videos. For this, we actually have harmonized legal provisions related to incitement to hatred, insult, defamations, and threats from 4 jurisdictions, UK, Netherlands, Germany, and France, to create labeling rules. We also have trained a team of legal experts, people with legal knowledge in the field, using the labeling rules to identify comments which contain abusive language. And we have created the first data set of abusive language on social media, but labeled by legal experts using these rules. We also try to compare in the future abusive language in various types of videos and topics. And a little bit more about this framework that we've created. So this framework contains legally inspired definitions to label the data for abusive language. So at first, we collected the data, like I said, from YouTube. When we collected the data, we wanted to collect the data representing the real world. So usually in previous research, people have been using keywords that are associated with hateful content to actually get more hateful content in their data set. However, there's no necessary proof that this actually ends up happening in your data set. So what we did was to just try and collect all the comments that were available on the YouTube videos without trying to bias anything using keywords. Then the definitions are actually inspired by legal provisions, and compared to what's being done in previous research, they maybe use their own definitions of what hate speech or abusive language is, or they might use the platform's definitions or just general dictionary definitions of what hate is. And then for the labels, we actually went a little bit further, and instead of just using binary labels, we tried to use a scale from 1 to 7, from 1 to 3 being non-hateful content, 4 being unknown, so unsure, and from 5 to 7 actually hateful content, with 7 being I'm really sure that this is hateful content. Then for the annotators, we have a team of 6 law students that have been trained to label data. And also very, very important, usually when people do annotation, they don't necessarily want to train the people that label their data. So what we ended up doing, even if we had legal students with some knowledge in the domain, so it wasn't so hard to explain them the concepts and so on, we still wanted to do some training. So we ended up doing 3 rounds of training where we went through comments with them and explained them if they had any misunderstandings or questions about how to use the rules to label data, or if they were doing something very different from their peers. So we had examples where one person would label something as hateful and the other 5 would label it unhateful. So we would end up discussing what is going on and if there's misunderstandings, because of course this is a very sensitive topic and also a very, very hard topic to actually label, because subjectivity can get into the mind of the annotators. And also, even if we do actually use legal definition, there's a lot of interpretation that goes on behind that. So it's kind of hard to put it in a box of, okay, this is hateful or non-hateful. And that was everything.
Okay, thank you so much. There's quite an interesting research and many applications, I guess. So let's see. Okay, we have questions. Thank you. Important work. Are your results relevant for organizations who work on mental health in youth, such as it is, with regard to cyberbullying?
I think they could be. I mean, right now we are focusing on the legal domain and how we can use that to improve the research of online harassment and abusive language, but also the results that we're going to get, for example, from the data set that we have, where we look at, I don't know, do we have more hateful content in veganism videos and so on? That could be helpful to see what kind of maybe social media platforms we should pay more attention to, or what kind of topic we should pay more attention to. And then this can, of course, be relevant to organizations as well.
Okay, good. So admin tells me we're a little bit over time, so I think we will keep it just to this question, but we can pick up on the questions also later. So if you want, I can send them to you. So thank you so much, and let's move on with our next speaker, who is Alexandra Emmendorfer. She's a PhD candidate at FPN, and she will discuss with us today irregularities or regularities in speech perception. So Alexandra, you have the floor.
Yes, thank you very much. So broadly speaking, the topic of my research is how we make use of different types of regularities in speech processing. But today, specifically, specifically, we're going to be discussing, or I'm going to be presenting some results from an experiment where I was investigating the mismatch response to phonological and temporal regularities in speech. So when language is full of regularities, and this allows our brain to make predictions about the upcoming speech signals. So for example, we can make predictions about the content of upcoming speech. This can be a prediction, for example, about semantics, like the upcoming words or the meaning of what we're saying. But the level that I'm interested in is phonotactic predictions. So this would be the combination of speech sounds. And in any given language, there are certain combinations that are more common than others. So for example, in Dutch, the combination TS is much more common than the combination TK. So we could say that the non-word not zal has a high phonotactic probability compared to the non-word not kal. We can also make a prediction about the timing of events in speech. And so this can allow us to direct our attention to when the next event is going to occur, so that we can listen a bit more efficiently. And the level here that I'm interested in is the stress pattern. So again, in any given language, there are certain stress patterns that are more likely to occur than others. For example, in Dutch, first syllable stress is more common than second syllable stress. So the question that I'm interested in is how the brain responds to variations in phonotactic and syllable stress regularities in speech. And I do this, or I investigate this using what's called an oddball paradigm. So here we record the activity, the brain activity, while the participant is listening to a sequence of stimuli. And typically there's one frequently occurring or repeating stimulus, which is called the standard, and that's represented here in blue. And there would then be one or more less frequently occurring stimuli, which are then called the deviant or the oddball stimulus, that's represented here in red or green. And the stimuli that I use in my experiment are non-words or pseudo-words, which means that they're not real words, but they're made to sound like they could be Dutch words. So, and I use words that are varying in phonotactic probability. So here again, we have notzal and notkal, and also in syllable stress. So we have first or second syllable stress. And I can present each of these words in separate conditions as a standard, as a formal deviant, which differs from the standard in terms of phonotactic probability, and as a temporal deviant, which differs from the standard in terms of syllable stress. And so this way I can compare the same stimulus that's presented in different conditions to each other. And the measure that I'm interested in is called the mismatch negativity. So you can see that here by looking at the difference between the red and the blue line. So red represents the deviant and blue represents the standard. And this component, if we create the difference wave, so we just subtract blue from red, we can visualize it a bit better. This represents change detection, auditory change detection. So whether you can hear a difference between two sounds. And if a change is detected more easily, then we would expect a larger or an earlier mismatch response, because then, yeah, your brain is just faster or better at detecting this change. So if we focus first on the phonotactic regularities, we expect that high phonotactic probability is processed more easily, because this is something that we're more familiar with. And so this would mean that we have a larger or an earlier mismatch negativity for the high phonotactic probability deviance compared to low. And if we look at the difference waves here, so the solid line is the high phonotactic probability, the dotted line is low phonotactic probability. This is in fact what we see. So the high phonotactic probability has a bit of an earlier response compared to low, and this means that we're a bit faster at it. So this difference in amplitude actually is not significant, the one that you see here, but the latency effect is. So we can confirm our hypothesis here that indeed high phonotactic probability is processed a bit more easily. Now moving on to syllable stress. Again, in Dutch, we expect first syllable stress to be processed more easily. So this then suggests a larger or an earlier mismatch negativity for first syllable stress compared to second. Looking at the difference waves, it looks like that's what we have, but unfortunately this doesn't reach significance. So here we're not able to confirm our hypothesis. So what does this mean? Why is this interesting? One of the applications that we see here is to understanding language impairments, such as, for example, developmental dyslexia. This is actually a study that's ongoing. So if you or someone you know qualifies, please reach out, because I'm trying to recruit participants still. So we know, for example, that individuals with dyslexia show some reduced sensitivity to, for example, phonotactic probability. And we also know that they often have difficulties processing rhythm. And so overall, understanding how our brain responds to these different patterns can help us understand how these regularities play a role in developing spoken and written language skills. So that would be my presentation. I just want to say thank you. And of course, in light of International Women's Day, acknowledge I'm not the only woman who's working on this project. In fact, all of my supervisors are women, which is wonderful. And thank you so much for your attention. Looking forward to questions.
Thank you so much for this most interesting presentation. So let me see. I also have some questions, but let's first give the priority to the others. Do you study native speakers? Have you also looked at not native speakers of Dutch? Ooh.
Yeah, I do study native speakers. So I haven't looked at non-native speakers of Dutch, but what I would expect there is that, yeah, the responses would be more related to, or I guess if we're saying people who learn Dutch as a foreign language, so they do understand Dutch, if that's what we're talking about then, I would then expect them to still see probably similar modulations. depending on their skill level in Dutch. So someone who's very fluent would probably see similar modulations. But depending on when they acquired the language, it might be a bit different, but that goes a bit beyond my current research, but I find it very interesting. So I would love to research that.
So as a follow-up, also about bilingual speakers, do you do research also, or?
No, at the moment I don't do any research on bilinguals, but that is actually, something I would really like to do down the road. So hopefully my path will go there eventually, but I'm not there at the moment.
Okay, good. Let's see, any other questions? It always takes a minute or so. Let's see. Okay. I think, no, we don't have more here. I think I got from the admin. Okay, very good. So thank you so much for this interesting presentation. I hope you continue with your research. I can see that it will have a lot of impact later on. So good luck. And let's move on to our next speaker, who is Dr. Giuditta Perversi. She's a lecturer at FSE. And her presentation will be about new materials for sustainable energy. ECO, very good.
Hi.
Hi.
Thank you very much for the introduction, Christina, and for organizing this amazing interdisciplinary event in which I'm going to put the hard science back in, but hopefully not too hard. So my name is Giuditta, and I will talk to you about the work that I do in material science, in particular material chemistry, that is related to energy applications. So the drill here is that I think we are all at least partially concerned with the idea of our energy future. So if you're wondering how can we make our energy more sustainable, it is an understandable worry, and we're right at being thinking what we can improve to make this better. And now, 2 points that I will say are very important for a sustainable development of our energy field is not making energy go to waste, and make sure that we're converting it properly to use it into something like technologically relevant, so that we can go forward with not wasting all of the energy that we are producing. On this point, electrochemistry can come to the rescue, and you might all be familiar with electrochemical devices like batteries, because we all tend to have a cell phone. Most surely, if we are looking at this presentation, we'll all have a laptop, and all of your devices work using this type of electrochemical devices. So a lithium-ion battery is the thing that powers your devices. But to make a lithium-ion battery work, you also know very well that every once in a while you have to recharge it. Other electrochemical devices, like fuel cells, instead will work on a constant supply of something that could be a natural gas or even a waste gas from an industrial setting. Now, if you manage to give it a constant supply, your fuel cell should work indefinitely. So it will keep working and keep producing energy as long as you keep the supply going. Of course, if you look at this picture, your lithium-ion battery is very tiny, and instead a fuel cells tend to be pretty big. So a fuel cell is not supposed to be in your pocket. That doesn't mean it's not applicable. Another key difference, apart from the size between a fuel cell and a lithium-ion battery, is that in a lithium-ion battery, you need to move lithium, which is tiny, teeny tiny. But in a fuel cell, the materials that are in the fuel cell need to be able to move oxygen. Now, these two things that you see over here are actually the ions to scale, so you almost have a 10-time size difference. So it's a very different business to try and move oxygen through a material, and also it's a business that tends to be only possible at very high temperatures. If we can improve the material, we could use fuel cells in way more applications because they will go down in temperature and they will be more applicable. Now, as material chemists, we have 3 key strategic needs. So what we want from our material is a material that is made with cheaper and more environmentally friendly components. We want to make it easy to like synthesize to make. So it's a material that you make easily and with methods that are perfectly reproducible. And the third point is that you want to bring this oxygen conductivity temperature, so the operative temperature of your device, down from 800 plus degree to a temperature that is more manageable. So what is our strategy here, in particular in the research that I'm doing at Maastricht University, is that we are choosing an established material like this barium indium oxide that you see over here. This material, we find it promising because apart from the fact that in itself is an oxygen ion conductor at very high temperature, it also has an arrangement of atoms in which you can actually sort of figure out that this should work pretty well. You can see these empty spaces in the arrangement in which the oxygen should be able to move. And as material chemists, we basically play Legos with materials. So you have your arrangement. Can you modify it? Can you change what's inside and make your material behave better? So what we do here is we look through the periodic table and we very carefully steer away from anything that might be performing but way too pricey. And we tend to stick to elements that you can easily find. You mix and match and you try to rearrange your material into something that will still work, but with a different composition, basically. And I'm happy to say that we do have preliminary results with this strategy that are kind of very promising, because it turns out that we can make another composition out of something similar to this one with way less indium content. That changes the atomic arrangement. So I did not make, and we did not make a material that looks like this with different composition. It changes shape. But by changing shape, we also significantly lowered the transition temperature. And we came about with a lot of underlining features that are super interesting. How do we do this? First of all, we do it in the Brightlands labs in Camelot, and with my students at the Maastricht Science program. So all the people that are making the material are actually my students hanging around. Thanks for the support of the University Fund Limburg and the university in general. We have this nice, shiny, high-temperature equipment, and we can do the traditional solid-state synthesis, which looks a bit like the big chemistry bake-off, in which you mix your powder, you put them in the oven, go. But we can also go on like variations on the theme to make something more creative with like solution-based synthesis, solutions in different atmospheres with this other type of equipment. And one thing that we need to make very sure as we go about doing a new material is that we know how it behaves and how that arrangement of atoms is structured. Because usually that you have a relationship between the arrangement of the atoms and the behavior in the physical properties. This is only feasible because we have like industrial collaboration and access to a lot of equipment and also additional students that are helping me comb through the data because it's a lot of data. And here what we can do is that if we know how the properties and the structure relate to each other, so how the atomic arrangement, composition, and behavior chain all together, you can then design a new strategy to make this thing even better. So this is a big, bulky work in progress. I hope I made you as excited as I am to see this coming in the future. And of course, thank you for the opportunity and thank you for all the support. And I'm happy to welcome any question.
Thank you for this amazing presentation. I know that we have at least one question. Let me see whether it will pop up. There it is. How do you go about confirming structures of the new material?
Okay, so one of those equipment that I put on the slide is an X-ray diffractometer, because the issue that you have with materials is that you need to look at the atomic distances and the atomic arrangements. Atoms are too small to be seen by a microscope. You need to actually go onto something that is more energetic, which is usually X-ray. And from the X-ray, you will get a signal that as a crystallographer, which is how I was trained, you're able to interpret. So I can see that the signature in X-ray of that original indium material is completely different from the one that I get when I make a new material, but the two signatures are consistent with only having one material giving you data. So I know that the new material is completely phase pure, so you don't have any impurity, but I also know it has a different shape. I hope this answered the question.
Okay, thank you. A crystallographer, what a nice thing to be. So another one, if you would have a new large research grant, what would you investigate next?
Okay, so with a larger research grant, it would be nice to have, apart from more structural data, so for instance, if you were to have a big X-ray diffractometer, what you could do is make your measurements of what is happening to the structure as you're making your structure heat up and conduct oxygen, because something might change as you do this. But to do that, you need to have an X-ray diffractometer, so an equipment that basically shoots X-rays on your material, a platform that will heat your material, and a controlled environment that will keep the atmosphere around your material steady. Another thing that tends to be pretty interesting is if you have your equipments for physical measurements all chained together. So, for instance, one thing that we used to do in another lab I was in as a research assistant was making sure that that thing that is conducting is actually oxygen, and you can do it if you mark the oxygen with an isotope, so something that has a slightly different weight, and then I can prove to you that your structure is spitting out oxygen as you warm it up. So, but these things tend to be kind of pricey, so large research grant will mean a lot more equipment, a lot more chemicals, and a lot of funky applications.
Okay, so I think that was it. The other one, we can skip it. I mean, we can, looking also at the time, we can ask it. You can receive the question at the end if you want.
Yeah. You know where to find me also, like don't hesitate to reach out on Twitter or by email. Excellent,
thank you so much. So now we move on to our final speaker, who is Alika Rogel. She's a bachelor student, so this is a great pleasure at FSE, and she will talk about geodesic motion, which sounds incredibly cool. So you have the floor, Alika.
Yes, thank you. Can you see my slides?
Now we can, yes.
Okay, thank you. Yeah, so thank you for having me here. And in the next 5 minutes or so, I will present you how you can calculate motion around supermassive black holes. So, as you might have noticed, gravitational waves are a hot topic now. They're also one of the interests of Maastricht University. In fact, Maastricht University is also investing a lot in gravitational wave research, also in the Einstein Telescope Pathfinder, which is a gravitational wave detector pathfinder. But before we can actually calculate gravitational waves accurately, what we need to have are the accurate descriptions of motion that then causes these gravitational waves. And this is actually the focus of our research here. So first, some background. According to Einstein, gravity can be seen as curved spacetime. So you can look at this spacetime here at the bottom left picture, and then you put some massive star on this spacetime, and the spacetime is then curved by this star. Now, if you put then some other objects on this spacetime, for example, a teacup, then this teacup will move in a way as dictated by the curvature caused by this star. As you can see here, so the teacup would eventually end up here instead of going straight ahead, as would be the case if there would be no star curving the spacetime. Now, a similar picture can be seen here at the top right, but this picture more accurately presents the actual content of our research, because in our research, we have here some supermassive black hole. So this supermassive black hole is then presented as this gigantic curvature of spacetime, But aside from this supermassive black hole, we also have a smaller star up here, and this smaller star is then orbiting around this black hole. And what we want to do in our research is to describe the motion of this small star around this big black hole. Now, to do this, you need to solve a very difficult equation called the geodesic equation. This equation is so difficult that even Einstein struggled to solve it. Now, then, what physicists do if we don't know how to solve an equation exactly? Well, we make an approximation. So how exactly do we do that? Well, we say, okay, the equation can be solved for a very simple case. A simple case could be, for example, circular orbit. I think we agree if there's one shape that's easy to describe, then that's a circle. So we start to describe our orbit with a circle, but then circle is not actually the thing that usually happens in nature. So we add corrections to the circle to describe our orbit more precisely. Now I have some pictures to illustrate this. So here we have exact orbit. That's a funny shape that we don't know how to describe. But we know how to describe a circular orbit. But you see there's quite some mismatch. So what we do, we add a small correction here in red to this circular orbit. And now we can see that the red orbit, which is the one with a small correction, almost matches the green orbit, which is the exact orbit. Now you can keep on adding small deviations until you get small corrections, until you actually get to as close to the exact orbit as you need. Then another interesting thing that happens in this specific context of this deviation method is that at each higher order, you get a number of free parameters. Now, what are these free parameters? You can see them as numbers that don't have their value specified yet, but you can choose them in such a way to better fit your orbits. So you can see this with an example of an elephant. So here you have an elephant that you can get by connecting the dots. Now, if you have a few dots, you can still draw an elephant, but this picture of an elephant is not super accurate. Now, if you add more dots, then if you connect those dots together, then your picture of the elephant already looks way better than this here. And you can actually see these dots here, analogous to free parameters that we use in our research. So, as having more dots here allows you to draw a better elephant, then having more free parameters allows you to better describe black hole orbits. Now, going to the results. In our research, we developed methodology for all corrections, which means that in principle, you can calculate the orbits around black holes to whatever precision you possibly want. And we did that explicitly for the first 4 orders. Now, this is the solution for the 0th order, for the 1st order, for the 2nd order, and this is a part of the solution for the 3rd order. I didn't include the entire solution because it unfortunately didn't fit on the slides. But I also made a small animation to illustrate how accurate these orbits actually are. So if we look at this animation, at the middle of the animation, there's a black hole, and these lines that go around are orbits of a small star. Now you can see there are three colors. So a black color means the exact orbit, then a red color represents the 1st order deviation, and you can see that the red and the black are different by quite a bit. But then if you add another correction, so the blue line, then the blue line, you can see that it almost overlaps with the black line, which means that the 2nd order already ensures quite a lot of accuracy. In fact, it goes up to about 99% of accuracy at the 2nd order already. But we actually develop a methodology to do this to all orders, so we can go even higher in precision. Now, we have our analytical expressions for the orbits around black holes. So what would be really cool as a next step would be to find what are the gravitational waves that result from this orbital motion. Now, this was all from my side. If you have any questions, please ask them. Thank you.
Thank you. So you're a bachelor student? And this is your research, amazing. Okay, so let's see what questions are going to come up. Yes, of course. Thank you for your talk. In the spirit of International Women's Day, I would like to know if you had a role model who inspired you to become a physicist.
Okay, so for a long time, I actually didn't like physics until I started university. And there was this gravitational wave conference in September 2018, I think. And there was actually a researcher and a teacher at Maastricht University, Gideon Kukuk. And yeah, he spoke super passionately about this whole thing. So I started to become interested in this kind of research.
Okay, so I let me see what other questions we're gonna get. I have one myself. Like I mean, I don't know much about it. One more question we have. Let me see. Yes, a nice talk. Are 4 orders enough for the mathematical calculation, or will further iterations be needed?
Okay, so that's a good question. So actually, while we calculated the first 4 orders, we didn't yet have time to investigate how accurate actually these orbits are. But we know for the second order that they are already 99% accurate, which is a very high accuracy. But in order, if we actually then want to use these results to calculate gravitational waves, then we need even more precise results than 99.9%, because a small deviation, small difference in the orbits results in a bigger difference than in the actual gravitational waves. So we expect that the 4 orders are already pretty good, but we still need to do some more analysis. And yeah, we have the methodology ready to calculate more orders if necessary.
Okay, I think that was it. Thank you so much for this most interesting presentation and this fascinating topic. Good luck. Oh, I hear from admin lots of nice compliments in the comments you got. So I'm like to read them later. So good luck and bravo. Fantastic research.
Thank you very much.
Okay, so that was it. I'm afraid our time is up and we have to close the first Women Researchers Festival of Maastricht University. We had 2 sessions of totally 16 researchers that presented a very diverse but very amazing research ideas. And also we had very good diversity of faculties, of disciplines, but also of levels. We had bachelor student, a master's student, very intimidating, by the way, up to professors. So that was most inspirational, I have to say. So I think that UM's women researchers truly rock the ground, and I feel so privileged to be among you. So thank you all for participating, the speakers, but also those who attend the event and post all these wonderful questions. Please note that the videos will be available at a certain point after the event, and there will be also posters from other research proposals that we received, which are equally fascinating, and they will be also visible in our website and the website of Pint of Science. There will be also an article discussing the event in the Moois Rijn Gazette, so there will be a follow-up after this. So I would really like to thank also Pint of Science for hosting this event and for providing all the support and admin and for advertising and everything. And yes, that was it. Thank you all for the participation. Enjoy International Women's Day and also your week. So bye-bye. Thank you all.
Thank you. Bye.
Bye. Thank you so much.
Bye-bye.